Hi, I'm Zahra Azizi, a PhD student in cognitive modeling at Institute of Cognitive Science Studies, Iran, Tehran. Last year, I attended NeuroMatch Academy and I really loved the experience. So this year, I decided to apply as TA. Multiple regression is an extension of simple linear regression. It's used when we want to predict the value of a variable based on the value of two or more other variables. Imagine you want to predict the weight of kids by their sex and their height. These two variables are independent and can predict the weight of a kid very well. In neuroscience, linear regression is used as well. I will explain tutorial 4 of week 1, day 3, to go through multiple linear regression and polynomial regression. Okay, so let's start. In the multiple linear function, we want to model y given a set of pictures as an input x, and we will multiply each x by a theta, which is represented here. Theta are the model parameters. We have to account for as you can see, for an additional theta 0 that's not multiplied by any inputs. When we want to show it in fully matrix form, as you can see here, we add an extra column 1 that is represented here because as it will be a matrix multiplication and we need to multiply by the theta zeros. Okay, so let's execute these cells. I have executed these cells before, and as you can see, here we have a two-dimensional problem. We have x1 and x2 as inputs, and we want to predict our y. What we want to do is to find optimal vector of parameter theta hat. Okay, so here we have to use this equation to solve our problems. Here we will use the ordinary square approach, and we will fill the function which is written here. And as you can see, we receive x and y as inputs, which are the only parameters we needed, and we'll return the theta hat here. So according to this equation, I will use a Python function inverse to compute the theta hat. So let's write it. Here is the function. I copy the functions here, and then according to this equation, I try to write it. Okay, transpose it, and then, oh, sorry. Okay, here we have x, and then, so let's see it. We have, okay, okay. So, okay, so now we should comment this line and uncomment these two. So let's run it. Okay, as you can see, we have our theta hat here, theta 0, theta 1, and theta 2, and it seems that everything is going well. So let's move. Now, now we have theta hat here, we can obtain y hat and compute mean square error. As you can see these quotes here. So let's run it, and The computed MSE is shown here, as you can see. So let's execute these cells to visualize data on predicted planes. And here it is. Oh, here it is. As you can see, we have our dots, our points, and x1, x2, and the predicted plane. And as you can see, the distance between each dots and the plane is the errors. And we have computed MSE based on that. So up to here, we